Hi guys, so we'll be discussing this question rotting oranges, which has been asked in many of the interviews in Google, Amazon, and other companies. So this is basically we are given a grid where there are some oranges present. 0 represents an empty cell, 1 represents that this position has a fresh orange, whereas 2 represents this position has a rotten orange. So every minute orange that is 4 directionally adjacent to the rotten orange becomes rotten. So we have to return the minimum number of minutes that must elapse until no cell has a fresh orange. If that's impossible, we should return -1. So here if orange is present at position 0, 0, it will start making the neighbors also rotten, which is 4 directionally adjacent. So in this case, let's see what will happen. So in this example, we are given the grid where 0, 0 position has a rotten orange and the other oranges in the row are fresh, and the same happens for the other grid. So this is the grid which we get. Here initially at time 0, this is the rotten orange, and in the next second what will happen, this and this orange will become rotten like this. And now due to these two oranges, its neighbors, which is neighbors of this orange, whereas neighbor of this orange, which is this one itself, will also get rotten like this. And and after that, due to this orange will get rotten. Due to this orange, this will get rotten. So it happens in around 4 minutes. So we can see how it's working. First these two got rotten, then basically this got rotten, then this, and then this. So it worked like this, and this. So this is like traversing first to the neighbors and then to the neighbors of the previous node, which reminds us of a breadth first search, right? Here minutes is nothing but the distance. Okay, the distance it takes to reach all the oranges in the grid, and secondly it's visiting the neighbors first, so both can be achieved using breadth first search. Hence we get the answer as 4 in this case. Now let's see the second example which I have drawn here. Now here this one is a rotten orange while the others are fresh oranges, okay, according to this position in example 2. So what happens in the 0th minute, only this orange which is at 0, 0 position is rotten. In the next minute, at minute 1, it will make this orange rotten. In the 4 direction, only this orange is the neighbor for the rotten orange. So this will become rotten. Next minute, that is the second minute, now this orange will make this orange and this orange rotten. Now this orange in the 3rd minute, that is the next minute, can make the oranges rotten, which is this one, and there is no other orange neighbor to this orange in the 4 directions. And this orange is also making this orange rotten in the 3rd minute, and in the 4th minute this orange will make the this one orange rotten. So here what we can see is that the orange present at position 2, 0, this one, is not reachable by any of the rotten oranges directly. We are unable to make all the oranges rotten, and the question wants us to return the minimum number of minutes to make all the oranges rotten. So here, as it is not possible to make all the oranges rotten, our output is -1. We can start coding this question. So let's store the rows length and column length of 0. Now we'll use BFS as discussed. Let me store all the rotten oranges in a queue, because we'll be traversing based on the rotten oranges using BFS, right? So for I in range of rows and for j in range of columns, we will use a queue where if grid of ij is equal to 2, then only we'll append these two in my list. Okay, and also if grid of ij is 1, okay, to check if all the fresh oranges are completely become rotten, let's keep a count for fresh oranges where I'll be incrementing fresh by 1 whenever grid of ij is 0. So now starting with the BFS traversal, while q for node in range length of q, we'll pop the indices of rotten oranges. So for dx comma dy in x comma y plus 1, now we are going to check all the 4 directions, right? So x comma y plus 1 and x plus 1 comma y. Now if grid of dx and dy is fresh, then I'll reduce fresh counter by 1 and I have to make this grid position replaced by a rotten orange, right? So we'll make position of the orange at this grid equal to 2, and also I have to calculate the minutes. So the minutes will be calculated here as we calculate the distance of BFS. Okay, so yeah, let me take, okay, minutes is 0 and it will be incremented, and this loop will go on until q is 0. Okay, what if all the fresh oranges have turned rotten and we are just traversing the graph, like if the first half of the grid has all the fresh oranges, whereas the second half of the grid doesn't have a fresh orange. So we can just stop until the fresh oranges become 0. Right here, if my fresh oranges are 4 and I've already encountered them in the first half of the grid, so why do I need to traverse for the second half of the grid? So we can also add here while q and fresh is greater than 0. So this loop will go on until we have fresh oranges, and once all the oranges are rotten, we can return minutes if fresh is 0, else -1. If we have some oranges which are still fresh, then that means all the oranges have not turned rotten and we return -1. Okay, and also the main step which I forgot is to append the new rotten oranges in the queue. Yeah, so I guess this is it. Let's try to run the code. Okay. I don't know why I gave a y here. It should be ij. list index out of range. This should be x minus 1 and y minus 1, because this is for the left and above orange in that position. Okay, so now it says my output is 2 instead of 4. The one more condition which we are forgetting is that what if x and y go out of the boundaries of the grid? Okay, so what is happening here? It is checking for the graph for the oranges and it's going outside the boundary. That's why this is not going ahead. Okay, the queue is getting emptied and the grid is not traversed properly. So here, if this is equal to 0 and my dx is in the boundary, see, it's greater than equal to, it's less than row, and dy is less than column. It's rows. Okay. X comma dy is less than row, and this is okay. So this is the problem. This also matters, the sequence of conditions, because it is checking for an out of boundary position and it can't find the boundary. That's why it gives this error. Now first the boundaries will be checked and then that position will be checked. So yeah, this worked. Okay, so our code is fast enough and 88% faster than the online submissions. So I hope you understood the code and the concept behind why we are choosing BFS in this question. So that's all, guys. Thanks.